Okay, so as I said that we've been cleaning the files again and again, which seems to be annoying. So that automation is also possible in through Makefiles, but the difference is that what is the target here? Because remember I said targets are in most cases file names. So these are exceptions. So at the bottom in line number 15 in Makefile, as you can see on the screen, we have a target called clean. Okay, and there is no dependency here. And line number 16 has the command name that corresponds to that generation of that target or corresponds to that target, which says RM, which is for remove, minus F is for force. It won't ask the user for a prompt. In some cases we have set those options in bash RC file where it will ask for a prompt, are you sure you want to delete this? It won't ask that. Minus F is to force delete, it is to force the remove. And then it has, and what do you want to delete? You want to delete all the object files. So you can take those object file names from the objects variable on the top. So you can say dollar parentheses objects, and you want to delete the main.exe file as well. Okay, so when you do that, let's try it out. Let me open Makefile 6. Oh, sorry, Makefile 5. So this on the right is Makefile 5. We already have the main.exe and the .o files available in our folder. So what I can say is, I can say make clean, because clean is a target available on line number 16 on the right hand side on the Makefile, but I have to force the Makefile 5. I give the file name Makefile 5. So when you do that, it runs the remove command available in line number 17, where it removes the .o files and the .exe file. So you note that it did not delete the output.txt because we did not provide that in the remove command. And that is typically what we do, because see, output.txt is a result of computation of many hours sometimes. It could be many days or sometimes many months. So if you've been running a code for many months which generated this output.txt, you don't want to delete it. All you want to delete is these intermediate.exe and .o files. But if you really want to delete, there is typically a target use called clobber that deletes everything that clean does, plus it also deletes all the output files generated. So in line number 19 and lines 19 and 20, we have the clobber target as well. Now these are not file names as typically targets are in Makefile. So on the top in line number 5, we have specified that clean is a target which is of type phony. Phony means fake. Okay. So it's a fake target, it's a phony target. So you specify .phony colon. So that gives Makefile some extra information that these targets are phony, they are not generating any file name. But sometimes even if you remove, if you don't mention that, it should work fine as well. So it's a good convention to include the fact that these targets are phony targets. So it gives the user also some idea when you're reading a Makefile, because that is what typically you'll do, right? If you're building a project that somebody else has uploaded on the internet, this will give you some understanding of what these targets are. So you can have many other phony targets like make plots, so that will generate plots. There is no plots as a file, but that's a target that generates plots for your project. Okay. Any questions? As I said that to make sure that you include a tab before the commands. So if you do not use tab or you use spaces instead of tab, you get some error which looks like saying make missing separator. It stops. So you can try it out yourself. So the last one that we have is Makefile 6. which has a help as a target as well. Again, it's a phony target. So in help, what we have is we have some helps available. Echo, as you know, is a command to print something on the screen. So we say echo and then we have some text. So let's try out makefile 6. So this is file 6. I can give a target help. So when you do that, whatever is between lines 20 and 25, they are basically echo commands, echoing some strings. So it tells that the valid targets available are main.exe, main.o, sub1.o, sub2.o, and clean. So also have output.txt as one target. Now you may notice that I have, instead of echo, I have written @echo, because whenever makefile, well, let's try it out. So let's do this make clean and then see what happens. So when I type make clean, what it does is it runs the command in line number 17, but before running that, it also prints the command. So it tells me the command it is going to run and then it runs it in the background. But if I use an echo command, echo by itself is printing something on the screen. So you don't want to see the command, otherwise it will print it twice. So let's remove from one of these and then use help. So now what you see is it prints echo valid targets. That's the command it is going to run, and then it runs it and prints the string valid targets. So to suppress those commands, you can use @, and that will only run the command. It will not print it. Running will still happen. So for example, if here in the remove I put an @rm, so what it will do is if I do a make clean, it does not show you anything, but it does remove it. I can show it to you. So let's do a simple make. So it generates these files, and now if we do a make clean, although it does not tell you what it has run, but if I do an ls now, the main.exe is gone. So you can see that it did remove the main and the object files. Okay. Any questions? Right. So lastly, now you may ask that if we have 100.f90 files, why do we need to specify the corresponding object file names in the objects variable? Why can't makefile figure out by itself what all f90 files are and replace and the objects variable should automatically get populated? Well, that is also, so make can do a lot of things. So here what we are doing is we are defining a variable called sources, which is using the wildcard command of make followed by star. So basically all the f90 files will get expanded to in the sources variable. Okay, so sources will have the list of all f90 files available in that folder, and then objects use the substitute command. So it will take the list of all the f90 file names and replace take the string .f90 with a .o. So it's saying substitute .f90 for .o in this list of all the sources in this variable or the list called sources. So sources, which has a list of all the file names, will get modified where .f90 gets replaced with a .o. Okay. Here this make file is simply listing those. It is just echoing the file names rather than actually using them in the make file for running the code. So let's try that out as well lastly. So let's clear it, and now we'll say make -f, make files -f. So what it should do is uh, it has only the default target is the first target, which is test. So it runs the test target, it echoes the sources and the objects. So sources are these 4 F90 files, and the objects are these these .o files. I mean, it basically replaces them with a .o. The files may not even exist as of now, but it simply is replacing the .f90 with a .o in that string. And now you can use that string or the variable wherever you want in the makefile. Any questions on this? So that brings us to the end of this discussion on makefile, and that is going to be the only discussion. We only had one lecture on makefiles, but we will be using that. In fact, if you remember in lecture number 1, we used this makefile. So I can take you to that lecture. Have made sense at that time. Since in last year's repository, I'll upload that later in this repository. So this folder lecture 1 will be uploaded. So it had a makefile there. So let's have a look at this makefile. Okay, so it had many targets. So the default target was Jacobi 2. The default target was, well, in this case the default target was the first one, but we had 3 phony targets. One was plots, one was clean, and one was clobber. So clean clobber is basically to clean files, but plots is what we ran. So plots target, which is a phony target, but that has a dependency. The dependency is solution.txt, because that file contains the data that you can plot on a file. And how does it generate the plot? It runs this Python script called plot_solution.py. So when you run this Python script, it takes the data, it opens the solution.txt file and plots the data. So if that solution.txt does not exist, it will have to create that. So solution.txt is another target which requires an executable to run. So that is your actual code that runs to generate this solution.txt, and that code Jacobi2d.exe depends on .o files, and these .o files are generated from, sorry, here on the top, from F90 files. So you can see there is no ordering as such. Any order can be there as long as it only checks for dependencies. The dependency checking is not based on the order in which you specify the targets here. It depends on the dependency file names or file extension that you specify. Okay, so please do have a look at this file. I'm sure this file will start making, the code will not make sense because we still haven't discussed that. We'll discuss that in a later class because it uses parallelization ideas, but the whole framework should make sense now, and you should be able to do something useful without even understanding how these F90 files are written. So we'll close this lecture now, but you still have some time, so please try out makefiles. I'll be walking around. If you have any questions, do ask, and I'll also be asking you to work on my square root of F90 if you haven't done that already.